Welcome everybody to our robotics class. This is week 34, and we are going to switch gears this week. We've been spending quite a bit of time inside of VexCode VR, which has been a real blessing, a free virtual robotics full curriculum. It's been very nice to be able to follow along and learn how to program robots, but I think we need a little break this week. So if you know code.org, our favorite code.org that we spent so many years in, they have a new series out all about artificial intelligence and robotics, and it's really interesting. So we're going to actually watch that series today, and then I'm going to have some questions for your homework this week as like your assignment. So what I would like you to do is just pay attention, please give your attention to the video. And learn something, because they have a lot of amazing things for you to learn in here. And then you'll get to follow through with the questions that you probably will have to type up. I'll let you know after, okay? So I'm going to put it on, and then I'll come back after it's done, okay? So here, let me start it for you guys.
AI is the most transformative technology of our time. From precision agriculture to precision medicine, from personalized e-commerce to personalized education, and from connected cars to connected homes, it's likely you're already experiencing many of the everyday applications of AI in your life. In this video series, you'll learn how AI works and why it matters. You'll see how with AI we can use data to train computers on just about anything. You'll explore how we can use AI to simulate neural networks in order to learn, and how AI enables computers to recognize objects too. And importantly, you'll learn about the broad societal impacts of AI and how to guard against unintended consequences. It's inspiring to see what AI can do in the hands of change makers who harness it to address society's most pressing challenges. At the same time, we must ensure we build AI responsibly, taking a principled approach and asking the difficult questions, like not what computers can do, but what computers should do. I'm excited to see what each of you will dream and invent with AI, and how you will apply this powerful technology to build the world that we all want to live in. I hope you enjoy this course. Thank you all very much.
My name is Ale Flores, and I'm a product manager at Alexa.
My name is Dr. Chelsea Haupt. I work at the Allen Institute for Artificial Intelligence, and I work on an AI-powered academic search engine. All around you, computers are making decisions, and those decisions affect your daily life. When you do an internet search or scroll through your newsfeed, computers decide what you see. Computers can already recognize your face and understand your voice, and soon they'll be driving cars and detecting diseases even better than humans. So how is any of this possible?
You may have heard about something called AI, or artificial intelligence. True artificial intelligence is decades away, but there's a type of AI called machine learning that is here today. It's a type of AI you probably interact with every day without even knowing it. And it has the opportunity to help us tackle some of the world's biggest challenges.
Machine learning is how computers recognize patterns and make decisions without being explicitly programmed. What's so exciting is that it's a completely different way to program a computer than what we've ever done before. With machine learning, instead of programming a computer step by step, you can program a computer to learn just like you learn, through trial and error and lots of practice.
Learning comes from experience, and that's true for machine learning too. In this case, experience means lots and lots of data. Machine learning can take in any kind of data, images, video, audio, or text, and begin to recognize patterns in that data. Once it learns to recognize patterns in the data, it can also learn to make predictions based on those patterns, like noticing the difference between an image of a car and an image of a bicycle.
AI and machine learning are playing a bigger and bigger role in society at large and shaping all of our futures. That's why it's so important to learn how it works with some hands-on experience. Remember, AI is like any tool. First you get the knowledge, then you get the power. Machine learning is only as good as the training data you put into it. So it's super important to use high-quality data, and lots of it. But if data is so important, it's worth asking, where does training data come from? Often, computers are collecting training data from people like you and me without any effort on our part. A video streaming service might keep track of what you watch, then it can recognize patterns in that data to recommend what you might want to watch next. Other times, you're directly asked to help, like when a website asks you to spot street signs and photos. You're providing training data to help a machine learn to see, and maybe even one day drive. Medical researchers can use medical images as training data to teach computers how to recognize and diagnose diseases. Machine learning needs hundreds and thousands of images and training direction from a doctor who knows what to look for before it can correctly identify disease. Even with thousands of examples, there can be problems with the computer's predictions. If X-ray data is only collected from men, then the computer's predictions may only work for men. It may not recognize diseases when asked to diagnose the X-ray of a woman. This blind spot in the training data creates something called bias. Biased data favors some things and deprioritizes or excludes others. Depending on how training data is collected, who is doing the collecting, and how the data is fed into the computer, there is a chance that human bias is included in the data. By learning from biased data, the computer may make biased predictions. This can happen whether the people training the computer are aware of it or not. So when you are looking at training data, ask yourself 2 questions. Is this enough data to accurately train a computer? And does this data represent all possible scenarios and users without bias? This is where you, as the human trainer, can play a crucial role. It's up to you to give your machine unbiased data. That means collecting tons of examples, often from lots of different sources. Remember, when you pick and choose data for machine learning, you're actually programming the algorithm using training data instead of code. The data is the code. The better the data you provide, the better the computer will learn.
Hi, I'm Dion. I'm one of the creators of Forethought AI. At Forethought, we build artificially intelligent tools that people can use at work to be more productive. To make a learning machine, early computer scientists looked for clues by studying other things that are good at learning. And it turns out that nothing is better at learning than the human brain. Our brains are made up of special cells called neurons. A neuron has 2 ends. Input signals enter in on one end, they're combined together inside the neuron, and leave the other end as a single output. All of the billions of neurons in your brain are connected to each other in what's called a biological neural network. It's how your brain processes information and recognizes patterns. Early AI scientists decided to mimic human neurons by making their own simple artificial neurons and software. Nothing fancy, just multiple signals going in as inputs, passing through the neuron, and getting combined and processed by some simple math into a new signal going out. And it's a good start. But one neuron alone doesn't do much. The full potential of this idea is only unleashed when the artificial neurons are connected together to make an artificial neural network. This is what allows computers to recognize images, drive cars, and make some truly weird art. To see how a neuron works, let's build a movie recommendation system that uses critics' reviews to guess how much you'll like a movie. Then we'll use your feedback to make the system better. Here are 3 movie critics, Ali, Bowie, and Casey. Each one rates a movie anywhere from 1 to 5 stars. Now let's build a single artificial neuron. Each of the critics' ratings enters on this side as input. Some calculations are done in here, and we get a single output. In this case, it's a movie rating. Here's the first movie. Ali gives it 1 star, Bowie gives it 5, and Casey gives it a 4-star review. At first, the critics' opinions all carry the same weight and are counted equally. The inputs enter, there's some basic math, and out comes a recommendation. Now, let's watch the movie so we can give it our own rating. Okay, that was weird. Let's pretend you really liked it and gave it a 5-star rating. The rating you just provided is now used to train the neuron. Based on your rating, the weight of each critic's opinion is recalculated. Your rating is closer to that of Bowie and Casey, so their opinions get more weight. You didn't agree with Ali's single-star review, so that weight goes down. Now let's train the neuron again. Here's another movie. And here are new ratings from our critics. And this time, the neuron will give more weight to these 2 ratings when calculating its recommendation. And here's the output. Now let's give it a watch. Well, at least that was short. Let's give it a rating. Our new rating adjusts the weights again. This process repeats over and over until we've trained a system to know our preferences and recommend movies that we'll probably enjoy. In this example, there's just 1 neuron. That's far more simplistic than most systems. Powerful neural networks have millions of neurons arranged in layers. There are input layers, any number of hidden layers, and output layers. The output of one layer of neurons becomes the input to the next layer, and so on. Many real-world media, music, and shopping recommendation systems work like this, using ratings from millions of everyday users. In those neural networks, everyone has a hand in modifying the weights. Neural networks have so many other uses. They're working behind the scenes on big problems like growing healthier food, predicting floods and forest fires, aiding wildlife conservation, and even detecting and curing disease.
Hi, my name is Alejandro Carrillo, and I'm a robotics engineer at an agricultural company. Specifically, my team uses machine learning and robotics and computer vision to identify the difference between the crops that we eat and weeds that take nutrients away, and we're able to remove those weeds without any chemicals.
My name is Kate Park, and I work at Tesla Autopilot. I build self-driving cars. Any place where there can be resources used more efficiently, I think is a place where technology can play a role. But of course, one of the best impactful ways of AI, I hope, is through self-driving cars. Have you ever wondered how a computer can recognize a face or drive a car? Or maybe you've wondered why it's so hard for a computer to tell the difference between a dog and a bagel? Well, it all has to do with something called computer vision, the way machines interpret images. Let's take a look at a simple example of how computers learn to see.
Here are 2 shapes, an X and an O. At some point, you've learned the names for these shapes, but a computer looking at these images for the first time just sees a bunch of little squares called pixels. Each pixel has a numerical value. For a computer to see, it needs to make sense of these numbers to figure out what is in the picture. In traditional programming, you could tell the computer to check which pixels are filled to decide what shape it sees. If the center and corner pixels are full, then it's an X. If the center and corner pixels are empty, then it's an O. Traditional programming works great for this kind of thing. But what about asking the computer to recognize these images? What might the computer think these are? We gave the computer a strict definition of what an X looks like. But these images don't fill all the necessary pixels to fit the definition. So if the computer doesn't think these are X's at all. In fact, the computer thinks these are O's because the corners and center pixels are blank. And that fits the definition of an O that we gave it.
In this example, traditional programming only works some of the time. But with machine learning, we can teach the computer how to recognize shapes no matter their size, symmetry, or rotation. Teaching a computer requires thousands or even millions of examples of training data and a whole lot of trial and error. So let's start training. Here are some simple shapes we can use to train the computer to see. At first, the computer is completely clueless and makes a totally random guess from a preset group of options. And it guesses wrong. But that's okay, because this is where the computer learns. After it makes a guess, the computer is shown the correct answer. It's like learning with flashcards. Sometimes you have to get it wrong before you get it right.
With every guess, the computer looks at each pixel and the surrounding pixels. It tries to recognize patterns and make rules to help it guess. Like if it sees a row of orange pixels next to a row of white pixels, there's an edge. If the computer sees two edges oriented a certain way, say a 90-degree angle, then it's likely to guess that it's looking at a square. It won't get it right every time, but with more trial and error, it will slowly build a more confident guessing algorithm.
Whether it's trying to guess shapes, animals, or any other category, machine learning finds patterns by learning from its mistakes. The training data is used to make a statistical model, which is just a fancy way of saying a guessing machine. When we give it training data, the guessing machine is tuned and optimized to recognize the pictures we gave it, with the hope that it will then be able to recognize new pictures with the same accuracy.
It may seem easy to tell the difference between an X and an O, or to even categorize basic shapes, but most images aren't that simple. Let's take a look at how computer vision can learn to recognize complex images, or scenes like ones in the real world. Most complex images can be broken down into small, simple patterns. For example, an eye is made up of two arcs and some circles inside. A wheel is made up of concentric circles and some radial lines. The way a computer recognizes the patterns in all these pixels is by using a neural network made of many layers. The first layer of neurons takes pixel values as numerical inputs to identify edges. The next few layers of neurons take those edges and try to detect simple shapes, until finally the computer puts it all together to understand the scene.
It can take hundreds of thousands or even millions of labeled images to train a computer vision system. But sometimes even that's not enough. Some face recognition systems have trouble even seeing people of color because the system was primarily trained with photos of white people. Sometimes problems in computer vision are silly, like when a computer gets confused trying to tell the difference between these dogs. Oh wait, that's not a dog. But it does kind of look like a dog. At least this dog.
But as society relies on computer vision for real problems, like detecting diseases in medical imagery or helping a self-driving car identify pedestrians, it becomes increasingly important that we all understand how these systems work and what types of problems they're appropriate for.
Computer vision can open up a miraculous world of possibilities, but a machine is ultimately only as good as the data used to train it.
No matter what field you end up going into, it's quite likely that AI is going to have some impact on what you're doing.
The potential for AI to help society is enormous.
It's something that is influencing a lot of very important decisions about real humans and their lives.
It could be used in education to be more of an equalizer between people. It could be used in healthcare to develop new drugs. It could be used in science to develop new technologies.
And like any technology, its application will depend on how it is utilized.
And at the same time, we need to think about the risks that are associated with doing that.
The consequences are huge.
The kind of artificial intelligence technology that really dominates the applications we're seeing today is machine learning. Machine learning depends entirely on the information that you feed it.
The problem is that with real-world data, there's often information in there that you didn't intend to be in there, but is captured because of the bias in the data collection process.
So if you're building an AI to determine who gets a home loan or who should be charged with a crime, it could definitely bubble up the racial biases that humans and our current society already does.
A lot of what it means to build less harmful AI is really systems that are including the perspectives of those that are most vulnerable or most marginalized, most likely to be hurt by the deployment of that system.
In many ways, I've worried that the people who are particularly vulnerable to AI are the people who are already underprivileged in many respects.
Most people in the world just have AI applied to them rather than playing an active role in guiding what AI gets applied to.
Everybody you know has a computer in their pocket. That's young people, old people, rich people, poor people. To me, that's actually quite exciting from a democratization of technology perspective. It means that AI, powerful as it is, could theoretically be in everybody's pockets, benefiting everybody.
We should strive to make sure that things that provide value for society can be reached to anybody.
How do we give a greater voice to the people who are being impacted by AI to in turn be able to turn around and impact how AI is used for them?
Every time when you're looking at a new problem, you have an opportunity to change the world. Sometimes we succeed, sometimes we don't, but we always try.
It's really critically important that we have as many diverse perspectives as possible influencing the development of AI. We need the participation of more women, more people of color, to provide a different perspective and a different lens on which problems matter and how we should approach these problems.
I think ethics becomes more important as something becomes more impactful. And as AI becomes more impactful, the more that we have to think about the ethics of AI.
Artificial intelligence is ultimately built by human beings. Human beings can have very diverse motives for why they make something.
Unfortunately, there's a huge difference between those that are involved in creating these systems and those that are impacted by these systems.
So what we really want to think about long term is where's the society we want to get to, and how is technology going to help enable that? If we think about that in the long term, we have a better chance of getting there than if we just try to develop the technology and then see what happens.
I have always been extremely inspired by the opportunity that robotics presents to enable us to do work that was too dangerous for humans, not possible for humans, or is done more effectively by a machine.
There have been millions of jobs that have really transformed because of the introduction of robots or AI, and that will continue to be the case.
As a result of that, when we design algorithms that are meant to replace people, we need to be attentive of how we do that and how we design those systems so that it respects those people and treats them with dignity.
When we think about artificial intelligence, we always put people first. We always think about who is that worker who's trying to get a job done and how can our technology help them.
What do we do in the long term? How do we retrain them for another job or another career?
As human beings, with all of our creativity and passion, we're going to continue to learn how to cooperate with artificial intelligence and have new jobs, have new job descriptions.
It is really important that technologists kind of have this mantra of ensuring that their innovation is ethical and is beneficial to everyone in society.
Machine learning requires a lot of true information to be provided to it in order to ultimately deliver a utility. This information might be very sensitive to us. It might be health related. It might be financial. It might be very, very personal.
We need to put checks and controls in place, like with any technology, that it's utilized to benefit us and that it is done with accordance to the law.
There's a lot to gain from involving yourself in really understanding the details of how this technology works. Given that it's so impactful, given that it is something that will influence your life and the life of everyone that you love.
AI is really at this kind of early stage that has this huge potential to do good. And if you're young right now and you learn this stuff now, you could really end up being at the kind of crest of a wave of something that's really important.
Okay, so we're gonna just stop right there. Hopefully you guys found that interesting. It was really nice overview and good introduction explaining more about AI and the type of AI that we're dealing with and machine learning, right? Teaching these devices and machines how to actually do different things and think on their own. So what I would like you guys to do is this week you're going to research one example of AI. So it could be something that you know in your life every single day that that you use. Hang on one. Sorry. So you guys are going to choose one example of AI, something maybe that you use every single day, something that you're interested in researching. And I want you to find at least one source on the internet, so an article talking about what you chose. And then you're going to just type up a summary, just explaining briefly how does it work? What about it is interesting to you. So you might need to do a little bit of research. So hang on one sec. So here's some examples you might want to look into. So some artificial intelligence today in our everyday lives: face detection, recognition technology, virtual filters on Snapchat, face ID unlocks on the iPhone. Those are some things you might want to do a little bit of research on. Let's see, what are some other things? Text editors. So it says several text editors rely on artificial intelligence. Social media, some social media platforms like Facebook, Twitter, Instagram, they rely heavily on artificial intelligence for various tasks. So you might want to do a little research on that. Chatbots. Some of these chatbots they rely on artificial intelligence. And so these are some search algorithms too, rely on artificial intelligence as well. Digital assistants, right? Like Google Assistant, Siri, they do rely on artificial intelligence. Smart home devices, right? Like smart thermostats, smart refrigerators. These are some examples of AI in our everyday life. So you're going to choose one of these and you're going to do some research about how does this use artificial intelligence or machine learning? How do these machines learn? So I would like you to find at least one source on this. I would say probably you might want to get more than one. So you're looking for one source. So it will probably most likely be an article that you find on the internet. And then you're going to read your article and learn a little bit more about it. And then you're going to type a summary explaining how it uses artificial intelligence. Okay, so I'm going to send you guys a little summary of what I'm looking for of your assignment. So it'll be like a 1-page Word doc. You'll have your name, you'll have the name of whatever it is that you're researching. So maybe you're doing like Face ID on iPhones. And then you're going to have like the link to your article. And then you're going to have a little summary of how it uses artificial intelligence. So that's going to give you guys the chance to look into something a little bit more and learn more about how it uses artificial intelligence. Okay, guys, so that'll be your assignment for this week. I'll send you more information on that. And then we'll pick up again next week. All right. Okay. Bye, guys.